Right. So I guess I'll be the representative for the Vortex Vultures today. So Shriya unfortunately wasn't able to join us, which is our instructor, because she's in an airplane. Another one of our members is currently stuck in a car in the middle of nowhere to another state. And the other one is also in another state, but cannot join. So today is just me and one of my other team members. So we were able to finish our model a little bit more earlier. And so we provided a video for you guys. I'll be providing the link to our website at the end once I'm done presenting the video. So without further ado, I'll be sharing that right now. Please let me know if you guys can hear it or not, because last time I had problems with audio. So yeah. Okay. Can you guys hear it just real quick?
Yeah.
Okay, that's lovely. All right, then I'll be watching. Hello, so today I'll be introducing our team. So we are the Vortex Vultures, and this is also our logo that is also AI generated. So today we will be showing you guys LeafLex, which is our model that we trained and that we implemented on our web app. So the team members for our team is Akshitha, Benjamin, Mirka, and myself, Valeria.
So for our project idea, we came up with a plant classification app called LeafLex. This was because one of our team members had trouble identifying parsley and cilantro they mentioned to us. And so we decided, why not help out himself as well as other people who might have trouble with identifying certain types of plants and basically help them out to identify these plants using a plant classification app. So for our MVP, minimum viable product, we created a data set with at least 1,000 images, and then we fine-tuned our model using vision transformers, as well as training the model with an 80% or higher accuracy, which we use these images to implement into our website. And so during this process, we were able to accurately identify about 20 plants that are commonly mistaken for one another. And this was able to be implemented into our website, and this made it a very fun and interactive website as a final product.
So for the backend part of this project, we used Python, transformers, and Flask. For the front end, we used HTML and CSS. Some of the obstacles that we had to overcome were adding the separate links to the toggle bar at the top of our website. It took a while to figure this out, but we were able to use Flask to make the separate links. Also, for training our data, it took a really long time. In fact, one of our team members, Valeria, she did it all night and it didn't work, so she had to redo it. Also, figuring out how to get the image exactly where we want it on our website was a bit tedious because we had to mess around with the sizing and the padding and the orientation. But eventually we did figure it out.
So moving on to the data set that we use in order to train our model, as previously said by Mirka, our first goal in order to achieve it would be at least 1,000 images, but thankfully we were able to reach 2,655 images. Within each class that we did, we at least tried to reach the goal of 150 images per class. And in total, we were able to make 14 classes. So to our regular data set, we also added different types of augmentation. In order to make our model more stronger and in order to have a better accuracy, we decided to implement different types of augmentation. So some of these were saturation, brightness, and exposure. So this would also help whichever user that was to include something that might affect the accuracy, our model would be prepared for it. So in our model, we decided to train using a vision transformers instead of another model such as YOLO V5. So vision transformers showed that it would give us a better accuracy for our images. And it also works a little bit more faster. We also use different iterations and epochs to improve our model accuracy. So for example, using the data set with the different augmentations, the epochs, having more of them would have helped our accuracy. For example, moving it from 4 and up would also help and train our model more. And our end goal was to at least have more than 80% of accuracy. And thankfully we were able to have that between the numbers of 80 to 88%.
So after we all put in our blood, sweat, and tears of collecting thousands of images, training the models overnight, and developing the front end and back end of the website, we finally came up with our final product. And here it is, LeafLex. So how it works is that you choose a file, and this file would be an image of what you want this AI model to detect it is. For example, if you have a picture of a tulip that you just took a picture of, you can upload it to this website. Then you hit predict. And then in the backend, the model would predict this as tulip, which has a probability of 0.84, which means that it is relatively confident that it is a tulip. And you could try many other images of plants. Yes, so other web pages include sort of the mission of LeafLex, and why do we develop LeafLex, kind of the history and lore of us of why we did this. And we also have a page that talks about each of us developers, of who we are, what we enjoyed working on, and how we contributed to each aspect of the project. And lastly, we talk about the data set that we used, which talks about the types of plants that we trained this on, and the data augmentation techniques that we used in order to make this model more precise and accurate. So we are very proud of the current product that we have, and if we had just a little more time to expand upon this project, we would add ChatGPT into it. And how this will work is that after the image classifier classifies what type of plant this is, ChatGPT will come in and generate text that tells you more information about the type of plant and other potential helpful information or recommendations. For example, if it identifies a plant as poison ivy, it will let you know that this is something poisonous that you shouldn't touch, and also give advice on what should be done had you touch poison ivy.
We also would like to add like a webcam feature. So right now we have the input as an image and then it gives you a prediction. Instead, having a live webcam instead would be useful for things like maybe you're going on a hike or just walking around. Yeah. Thanks for listening to our presentation.